We're looking at the lattice rectum of an ellipse. The definition is lattice rectum of an ellipse is a line segment perpendicular to the major axis through any foci and whose endpoint lie on the ellipse. So basically, it's a line which is perpendicular to the axis, right? We have the major axis, so it's perpendicular to that. You can see that. And it passes through the foci, actually one focus at a time, and starts and ends at your ellipse. So basically we have two of it. Now let's derive the expression for this, we'll call it as L, in terms of A and B. So how will we start off? First we need coordinates for anything. So this is focus, say 2, and that's your 1. So focuses are at a length of c comma 0. Now this length is L. From F2 to say point M, the length is L. So the coordinate of M is c comma L, right? It's c units to the right and L units up, and so we have c comma L. Now here I'll make use of equations of the ellipse to derive it out. So we know that x squared by a square plus y squared by b square is equal to 1. This is your equation of ellipse. Next, what else can we do? We can substitute at M. What do we have? At M we have x to be equal to c and y to be equal to L. So this would be c square by a square plus L square by b square. Remember, we are trying to get an expression for c. But we know that c square is nothing but a square minus b square. It's a simple trigonometric expression. So we have a square minus b square, this entire expression divided with a square. I don't want to waste steps, so I'll divide each of them using distributive property a square. Okay, and then we have the remaining things to remain the same, that is L square by b square is equal to 1. So please understand, c square I'm writing this way and using distributive property to write this. Again, I don't want to waste steps. This results in 1 and we have a 1. We can cancel ones again. So we can cancel both the ones. And so we are left out with minus b square by a square. Again, we should not be wasting steps, so I'll just write it in this manner. So this is equal to 0. And now we have a rearrangement. L square by b square is equal to b square by a square. Remember, L is the half the length. And then we have L square is equal to b to the power of 4 by a square. And on taking square roots, what do we end up with? L is equal to b square by a. On taking roots. So finally, this is L. The length of the lattice rectum will be double of this. Length of lattice rectum will be 2 times of L. So this will be 2b square by a. distributive property. So c square I'm substituting as a square minus b square, and a square b minus b square by a square. So things will get cancelled and so on and so forth. And 1 will cancel at both ends. We have 1.